6.2, solve quadratic equations and solving quadratic equations by factoring. Okay, so quadratic equation, any equation written in this form, ax squared plus bx plus c equals 0 or equals y, okay, where a does not equal 0. So all that means is that it has to have that x squared term, okay, and then a, b, and c are just elements of the real number system. Okay, so here are some examples. X squared plus 8x plus 12, it has an x squared, so it's a quadratic equation, okay? 16x squared minus 100, it still has that x squared, so a does not equal 0. And then x squared plus 8x. And just note that the degree on the other x's is 1. Okay, so we don't have a y squared, we don't have an x in the exponent. So solving quadratic equations by factoring. What we're going to do is we're going to find the x-intercepts, and then there are 4 steps. So we're going to write the equation in standard form first. To find the x-intercepts, we sub y equals 0. Okay, we've seen this before. And then we're going to fully factor. And then what we're going to do is we're going to set each term that has an x in it equal to 0, and we're going to solve for x. Okay, so the whole point behind this is if we have 2 brackets, so like x minus, let's just do x minus r, x minus s. Okay, the whole thing behind this is that either this bracket has to equal 0 for this entire side to equal 0, or this bracket has to equal 0 for this entire side to equal 0. Okay, so we have to satisfy one of these equaling 0. Okay, and then when you hear the word roots or solutions, these are just values that make the variable, or values of the variable that make this equation true. All right, example 1, solve each equation for x. So this one's already factored, so what we're going to do is we're going to take these down, we're going to split them up, and we're going to put x minus 2, which is this expression, and we're going to equate it to 0. So when we bring this over, we get x equals 2. Now we're going to do the same for this expression here, x plus 3, okay, identical, and then equals 0, x equals negative 3. So the two numbers that satisfy the x's in here, so that this half of this part equals 0, well, if we sub in a 2 here, it's going to equal 0, or a negative 3 here. So there are actually two numbers for x that satisfy this equation. Okay, so what about b? This term has an x in it, so we set this expression equal to 0, and it's already done. Okay, so when it's just an x out here, it's x equals 0, and then x minus 4 equals 0, and then we rearrange, x equals 4. So there are two different ways that we can sub in numbers for x here and it equate to 0. Okay, I'm going to scroll up. Okay, we're going to find the roots, but first we're going to factor. So what if we're not given our equation in factored form? Okay, so what two numbers multiply to 14 and add to 9? Well, the factors of 14 are 114 to 7. So these two are going to add to 9. Those are going to be our factors, x plus 2, x plus 7. Okay, so if we branch these off, we get x plus 2 equals 0, so x is going to equal negative 2. And we get x plus 7 equals 0, so in this case, x is going to equal negative 7. In this one, we have 2x squared plus 5x equals 0. So we're first actually going to common factor out this x, and we're left with 2x plus 5, and then equals 0. So now we can branch off x equals 0, and that one's already done. And then we can branch this off, 2x plus 5 equals 0. We have to bring over this 5, so we have 2x equals negative 5. And we're going to divide by 2. X equals negative 5 over 2. So the two answers here are x equals 0, and x equals negative 5 over 2. Okay, let's keep going. So a little bit of a factoring review here. So 16x squared minus 9. This is difference of squares. So can we factor 16x squared? Yep, it's 4x. Can we, root. Can we root 9? Yes, it's 3. So how we factor this is 4x plus 3 and 4x minus 3 equals 0. So now let's branch these off. We want to know when does 4x plus 3 equal 0 and when does 4x minus 3 equal 0. Those are the two situations. So 4x equal negative 3. We divide both sides by 4. X equals negative 3 over 4. And we do the same to the other side. 4x equals 3. And we divide out. X equals 3 over 4. Okay, D is not in standard form yet, so what we want to do is we want to just simply bring these two terms over, and then we're going to get 2x squared plus 7x plus 6 equals 0. And now we go ahead and factor. So this is actually decomposition because the coefficient of x squared is not 1. So we need to find two numbers that multiply to 12 and add to 7. So the factors of 12 are 1, 12, 2, 6, 3, 4. So 3 and 4 add to 7. So we're going to actually break down this middle term into plus 4x plus 3x plus 6 equals 0. So this 7x now looks a little bit different, but it's equivalent. 4x plus 3x. And now what we do is we factor by grouping. So let's factor out a 2x, and we're left with x plus 2. And let's factor out a 3, and we're left with x plus 2. And now we common factor one more time out of these two terms. We common factor out the x plus 2, and we're left with 2x plus 3. Okay, this simplifies to x, I'll do the full work. X plus 2 equals 0, so bring it over, x equals negative 2. And this simplifies to 2x plus 3 equals 0. We bring that over, 2x equals negative 3, and then divide out. So I get x equals negative 3 over 2. I'll box that. Okay, next one. We have 3x squared plus 12x plus 9. Well, I recognize immediately that we can factor out a 3. So let's go ahead and common factor x squared plus 4x plus 3. Now, what two numbers multiply to 3 and add to 4, right? Because the coefficient here of the x squared term is now 1. So we can just simply do product sum. So I get 1 and 3. So we don't have to do the full decomposition. We can just say x plus 1, x plus 3. So I want to point this out. The 3 does not have an x term on it, so we don't have to consider that. We only need to know when, like what numbers we can plug in for x in order to make this entire side 0. Well, 3 is never going to equal 0, so we can just leave that, okay? So when does x plus 1 equal 0? Well, bring that over when x equals negative 1. And when does x plus 3 equal 0? Well, when x equals negative 3. Okay, I'm looking at this, and the 16x squared I know I can root, so I get 4x. And the 9 I know I can root, and I get 3. So let's just check if this is a perfect square trinomial. Root of the first times root of the second times 2. Yeah, I get 24x. So this is a perfect square trinomial. So this one actually just breaks down into 4x plus 3 squared. And that's it. Okay, so because this is the same, like if we expanded it, we would actually get 4x plus 3, 4x plus 3. We know that these are identical, so we don't actually have to even like solve this twice. this means that the vertex lies at this point. So when we bring that over, 4x equals -3, and then divide out that 4. Okay, so that means that the vertex lies right here, whether it open up or down. Okay, so there's only one x that satisfies that equation this time. Okay, and last example, write the quadratic equation in this form with these two roots that goes through this point. So here's the thing. We need to write in the standard form, but we're given roots. So this form is useless. We need to start by plugging these numbers into the factored forms, again, since we're given roots. So let's go ahead and plug -4 into r, 5 into s, and 8, 4 into x comma y. So we get 4 equals a, and remember, the x is in here twice, so we get 8 and 8 again. Okay, -4 turns into a +4 in the brackets, 5 turns into -5. Okay, so 8 plus 4 is 12, 8 minus 5 is 3. I get 4 equals 36a, and if we divide out, I get a equals 1/9. Okay, so our equation's actually y equals 1/9, x plus 4, x minus 5. Okay, since we have an equation in factored form now we can actually put it into standard form. Okay, so now let's go ahead and expand. So let's leave the 1/9, and let's expand. This goes to x squared minus 5x plus 4x minus 20. Okay, let's collect those two terms in the middle. So we get -5x plus 4x, I get -x. And now let's go ahead and expand that 1/9 into the bracket. And that's just multiplication, so I won't slow down there. And that is our equation, our quadratic equation in standard form with these two roots that goes through this point. Okay, so don't just think that when you are given two roots, or when you're given like the standard equation, you have to use the standard equation first. You can use something else first and then convert it.